just for giggles here.
Go ahead.
And okay, today are you yeah, you're just going to go through here. You should go through. Well, we only have Sean that's online. If you can Zoom, are you connected? Can you connect to Zoom also, and put your presentation maybe through Zoom, and that way Sean can see it too. Otherwise, he's going to be watching a camera of the projector. Hmm? You can wave at him. Hey, Sean, you there? Hello. Hopefully he's there. He is muted, but if he hears me, then.
Yeah, I'm here.
Oh, okay, good. Yeah, we were just wanted to make sure you can watch a presentation as well. Okay.
Yep, thanks.
And I think screen is, yes, screen sharing is now on, so you should. Whoa.
I got it.
Yeah, okay. Yeah, you can actually, let me turn off let me mute.
Can you hear me now?
Yes, thank you.
Okay.
I have my audio here muted.
Sean, can you, my audio is muted here, but
Let me unmute mine. Sean, do you hear everyone okay?
Yeah, now there's an echo though.
So, Sean,
You saying anything?
Can you hear me?
Sean, do you hear us?
Pull up the chat.
Yeah, see if you're saying anything in there.
Yeah, where's my chat? Here it is.
There's an echo.
Okay,
why
let me
don't you
turn my
mute your-
mic off.
Yeah,
okay.
I'll just put mine on. Okay, is that better, Sean? Okay, cool.
Okay, good.
All right.
All right.
So we've got some IT admins to manage all this stack. You got to have a business team to manage all the different costs, and there are quite a few, including forecasting. You're going to have a facilities guy to manage all the building stuff where this stuff lives, the HVAC and all that other fun stuff. And you're going to have to hire facility security, somebody like this mean guy making sure people can't just walk in off the street and compromise your server hardware. And here's the really fun part. This is all just for one site. If you want to have a globally available IT service, you have to take all this stuff, all this complexity, all these people, and copy and paste it all over the nation or even all over the world. Kind of a lot of work. Essentially, you're getting into three businesses in one. At the bottom of the pyramid there, we've got facilities. You got to own the buildings, the air conditioning, physical security. In terms of the hardware, you've got to have the servers, the network switches, all the backups. And of course, the software comes at the very tippy top. That's what we're actually paid for. We think we're in that. We're actually in three different businesses at once. It basically is. 3-tier. So the question is, can't we just code? We want to make a cool open source application for our customers. Can't we just focus on that and not have to worry about all that other crap? Well, especially if you're a smaller company, if you're an entrepreneur or you work for a small business, you probably can't afford all that stuff. And even if you can, you still don't have the same purchasing power as companies like Dell, HP, Amazon, Google. You can't compare with that. So we're all logical people. Let's think about this like logical adults. We don't have our own power plant because we're not a power company. We pay for electricity. We're not a real estate company, so we may not own our own building. We rent a building. So why don't we rent our hardware too? I mean, we're a software company. We want to make great open source software. Can't we just focus on that? And the answer, of course, is yes, we can. I am a huge Jim Carrey fan, and I had a lot of fun making that slide. So something like Amazon Web Services, which I'm going to use as my stand-in example for the cloud, they handle this a little bit differently. So the pyramid here has been shifted a little bit. At the bottom, Amazon owns and operates all the facilities where the physical hardware lives. So you don't have to have offices in Ohio and Virginia and South America and Asia and everywhere. They've already done that. They hire all the people. At the top, by the way, I work for MIM Software, so where you see manage by MIM, let's just substitute in mentally our open source software company. At the top, we've got the software that we ourselves make. Remember, this is the thing we're actually getting paid for by customers. And in the middle, it's kind of split 50-50. On the one hand, AWS manages the physical hardware. So they install and rack the servers. They do all the fine cabling for $50 an hour or less. It's a pretty good rate for that, actually. And we make virtual hardware that behaves similarly to its physical counterparts, but is easier to manage. It runs on top of the physical hardware.
I have to say, for $50 an hour, I'd probably go back into racking.
I probably would too. That's good money.
I could use some stretching wings.
Yeah. So thinking back to our earlier example, this is a admittedly highly simplified example of how we could do something similar on AWS. We've got a couple of virtual networks here. The arrows are logical connections, not physical connections. So we have no cables to run. We can logically say, I want network A to be able to connect with network B. And we've got a couple of virtual machines in each. We've got maybe a application virtual machine and a database in each. We've got them connected. The monitoring is all built in. And on the right side, we've got a different set of people doing all this. We've got the admins, we've got biz, but for the first time, we've got developers able to do this stuff. And the really cool part is for any other regions, this is so simple and so much more lightweight, it's easy to scale something like this worldwide because none of these people have to be locally where the data is. And that's the magic of infrastructure as code. Everything that we're dealing with that we saw in the last slide is all software-based. it has management APIs. So IT can code infrastructure rather than doing the racking and stacking, insert the ISO, install Linux or whatever. It's all just ready to go for us. And for the first time, engineering can help. We as the IT guys don't have to do all this ourselves. They can help write with infrastructure code. Now, just because something has an API doesn't mean that it's easy to use, of course. There are a lot of different ways that we could implement this. You've got tools that are built in like the AWS CLI, which you can use if you want to for like really small scale stuff, or you can use the AWS SDKs. So it begs the question, do we need to roll our own tooling for this? Especially considering the scope of these typical cloud platforms like AWS that provide so many different services. Do we have to develop all this stuff on our own? And the answer is no. He's back.
Justin is right.
That's right. That brings us to the topic of tonight's presentation, which is HashiCorp Terraform. And if you take away nothing else to this, remember this. Terraform is a command line based cross-platform infrastructure as code tool.
And those are the vagrant people.
That's right. Exactly.
No, that's not a joke, folks. That's one of the great Python virtualization tools that existed before the whole.
Mhm.
Yes.
They make a lot of
They
great
know-
stuff,
they
yeah.
know some stuff, and this is good.
Vagrant.
Yes, it's called vagrant because.
It allows you to get these pre-configured virtual machine templates and spin them up. They're called Vagrant boxes. You get a box that has like Linux installed, and then you say Vagrant up on the command line. It just spins up a copy of whatever the image has. It's pretty cool, actually. I used to use it for testing.
They're great.
It was a joke about the guy standing.
Oh.
In fact, if you want to look at some, you can go to vagrantbox.es, like España, and see a bunch of vagrant boxes.
There you go.
That's interesting. Might be a software itself.
That's right. Now, if you've seen infrastructure as code before, you may say, okay, I've heard about this mentioned before. There's stuff out there like Puppet and Chef, Ansible. So how does this compare? Or are they more or less the same thing, or what's the deal there? So Terraform versus Ansible, actually, they do play nicely. There is some amount of overlap, like you can use one for the other's main focus, but they each have a very distinctive focus. Ansible is focused, and Ansible, Puppet, Chef, things like that, are focused on managing things that already exist. So you've got a Linux server somewhere. You can use Ansible, Puppet, Chef, whatever, to install the Apache web server or whatever application you want, and it's good to go. Terraform is more based on building out the virtual infrastructure that we just saw, and possibly spinning up new servers as well. So you could do it kind of like as a layered approach. With Terraform, you build out virtual infrastructure where your stuff can live. You get a couple of servers going. And then with Ansible, Chef, Puppet, you manage the servers that have been spun up. So they each target different things, and they can be friends.
Does Terraform have some of those capabilities as well as managing the virtual machines?
Mhm. It does to a certain degree, although it's definitely more focused on the infrastructure side of things. Just like Ansible can technically spin up AWS infrastructure, but it's kind of messy. As software projects go, Terraform is actually fairly young. It was initially released in 2014. It actually has yet to get a 1.0 release even after all this time.
Wow.
Yeah, long beta, like Google level before you get to the actual general release, I guess. Terraform, I am pleased to say, is an open source project licensed under the MPL 2.0.
What is it?
That's a good question. Can anybody answer that? Pop quiz. Who knows what the MPL 2.0 license says?
Is it the MIT public license?
No.
Wasn't there a 3.0 that was a lot more restrictive, or one of them was real restrictive?
You're thinking of the
That's
GPL.
GPL, yeah.
The MPL is kind of a halfway point between the permissive licenses like the BSD license and the restrictive ones like the GPL3. It has a copyleft portion only on the original code from the developers. So if you have your own proprietary add-ons, you can do that.
Mhm.
But if you make any changes to the actual Terraform product itself, those have to be released. Yeah, those are copylefted. It is developed by HashiCorp. This is not somebody's fly-by-night project. Well, not they already picked it out, but they are a remote-first global company with over 1,000 employees worldwide. This is a big global company. And they also develop Vagrant, like Dante noted, and Packer, which is a super great tool I would love to talk about some other time. Packer is a tool for building different types of virtual machine images. such as VMware, Hyper-V, Docker, you name it, Packer can build it. It's super slick. It's really nice. So if you've used AWS before, you're probably thinking, aha, these cloud platforms already come with an infrastructure as code tool. Like for AWS, it's AWS CloudFormation. Why would I want to use Terraform over this? I mean, other than open source is always better because we're Linux guys and we love open source. Well, AWS CloudFormation supports AWS, that's it. Terraform supports infrastructure as code with over 100 different providers.
Oh, nice. Any chance do they deal with, I'll ask you later, sorry.
Sure.
DigitalOcean?
They do actually.
Ooh.
And a provider is simply a plugin that tells Terraform how to make API calls to manage a certain platform. And a platform can be anything from something like AWS, Google Cloud Platform, to services like DigitalOcean that are a little bit smaller. And they're really easy to write to. You can actually, if you know a little bit of Golang, Terraform is a Golang-based tool, and you can write your own provider. Real easy to put together. So by doing this, you avoid vendor lock-in. And you can also support projects that use multiple platforms. So suppose you want to have half your project on DigitalOcean, the other half on AWS. You could do that all with Terraform.
And with one set of code base.
Right, one
Which
code
means
base.
if one goes down, you're still back at work. You just say, "No, no, no,
Yeah, something like that.
no." Not quite.
Well, at least
I wish it was that
you can
simple.
move from platform to platform without being locked in, which is probably bigger factor than anything.
Oh yeah, especially with the big guys like AWS and Google Cloud Platform, they want you to use just them for everything. This makes sure they can't do that. So coding in Terraform is really easy to learn. I know I joke about this all the time, and I say, if you ever find an IT guy who says, this is easy, head for the hills. But this actually is easy, and I promise it's actually easy. I'll even show you a code example to prove it in just a moment. Terraform code uses HCL, the HashiCorp configuration language, which sits somewhere between like a bash script and a full-fledged actual language like Java, Python, et cetera, in terms of complexity. Whether you want to step up or step down, it's really accessible to people from both audiences. And as a bonus, HCL is used in other products like Packer. So if you know HCL and Terraform, you can use Packer, you can use many other HashiCorp products as well. And their products are totally awesome. And they're, I think, almost entirely open source. So a little bit of difference with HCL, though, is it is a declarative language. If you don't really know declarative versus imperative, it's sort of like the two different schools of thought when it comes to making a programming language. Imperative languages are what we think of typically whenever we think, I'm going to write a program. It's step-by-step code, like read this value in from the user, print this, connect to that, whatever, and done. That's imperative. With declarative, you're not writing the step-by-step instructions. You're saying, this is what I want the end result to be. Then you give that to the program, and the program figures out how to make that happen. So you say, I want to have 2 virtual machines on AWS and a database. You just hand it over to Terraform, and Terraform behind the scenes figures out what API calls it needs to do to make that happen.
Can you tweak it afterwards?
Oh yeah. And it will read in what it currently has, and it will then calculate based on that what it needs to do to change it. So if you say, initially, I want to have 2 VMs, then you say, actually, I want 10. You just change an integer, you rerun it, and it spins up all the more VMs you need. Nice and simple.
Yes.
Okay, so how simple is this? This here, it's a little bit hard to see, but if you can all squint or come closer or something.
How about if we hold the table back a little bit? That's just chair.
I want you to take a look at this and see if you can figure out, not having ever seen Terraform code, what this does. This is a very simple Terraform program that I have written. See if you can figure out what it does. I'll give you a minute or so. After Shut up.
You only have a minute. Oh, yeah.
So this program does 3 different things. We're going to look at these 3 different blocks there, the Terraform, provider, and resource. The Terraform block says we're going to use the AWS provider. And remember, the provider is simply a plugin that allows the Terraform engine to interact with a certain service. So we're going to interact with AWS. So we're going to import the AWS provider. In the second block, we're going to configure that provider. We're going to say, if we don't specify a region for the resources we create, because you have to specify an AWS region for your stuff to live in, then we're going to default to US West 2. which is, I think, Oregon. And then number 3 is we're actually going to create an AWS instance. That is an EC2 instance. And an EC2 instance is simply a virtual machine that lives on AWS. They call it an instance rather than a VM. Why? I don't know. We are going to base it on a template. An AMI is a template for EC2 instances. We're going to use a certain template, and we're going to make it a certain size. The size, like T2.micro there, just says we're going to give it, X number of CPU cores and RAM and storage and that sort of thing. And then we're going to give it a tag. So all in all, we're going to use the AWS provider, we're going to use the US West 2 region, and we're going to make a virtual machine. That's what we tell Terraform, and it will turn that into API calls to make that all happen. The basic unit of code for Terraform is a module, and a module is simply a folder with any number of HCL files that all end in .tf in it. Modules should ideally create one type of asset. So we just use an EC2 instance as an example. So we could have a module that will create an EC2 instance like that. The cool part is modules can use other modules. You can build sort of a code library like this. I think that's mine, isn't it? Somebody give me my phone. Excuse me. Better not be my phone. That's what I call people my public.
Oh,
Yeah, they're having a rather nasty network problem that IT is going to have to deal with because I'm no longer in IT.
Oh. Yeah, it's a good time not to answer the phone.
Yep. Gosh, I'd love to, but I'm talking about so many other cool things right now.
I had to finally do that work. I just saw who was calling.
Aye. So by building these modules, you can make a code library. You can have meta modules that pull in smaller modules. So suppose in our earlier example, we had a virtual machine and a database. We could have 2 modules, one that makes a virtual machine, one that makes a database, and pull them in with a second module. These are all stored in a project layout sort of like so. This is how I would typically do it when I do my stuff at work. It's all folder-based. These are all just ordinary files and folders. We're going to start with a folder for the environment we're going to deploy to. So like production, testing, development, that sort of thing. Then we're going to have a subfolder that has for each region we want to deploy to. So like US East 1, US East 2, whatever AWS region we want our stuff to live in. Within that region, we're going to have a folder for each individual module that we want to deploy. So here we've got one for the EC2 virtual machine and the database. And then each of those modules in turn has any number of .tf files. And all those .tf files are HCL formatted files. Terraform will read all those in, it will combine them together and put together its battle plan of what to do to make that stuff happen. Modules themselves are actually not very complicated. If you can get a couple of basic concepts down, you can be a pretty decent Terraform programmer. This is not difficult to pick up. Most modules are comprised of at least 4 different types of blocks. I'm going to call these the Fantastic Four. If you can manage these 4, you can make a Terraform module. So resources, data, variable, and output. We're going to be talking about each of these individually. A resource is simply something that Terraform should create, like a virtual machine. A data block will retrieve information. A variable block will, well, you know what variables do. I don't need to explain that much to this audience. And an output simply takes in information from resources or data and outputs it so that other modules can pull it in. So starting with resource blocks, these are similar to functions in traditional programming languages. So we could have something to create an EC2 virtual machine, a database, et cetera, et cetera. It accepts variables or constants as inputs. These are all very well documented on the HashiCorp website. And they return outputs that can be used by other blocks if necessary, or other modules. So suppose we want to create a virtual machine on EC2, and we want to have the ARN for that available to something else. The ARN, by the way, if you're not familiar with AWS, is the unique identifier for an AWS resource, kind of like the universally unique ID for it. So we could have that passed to something else if we wanted to. So that's a resource block. We saw one of those in the example before. A data block is like a resource block that doesn't actually create anything. What it does instead is it fetches information about some resource from the Terraform provider. So suppose, for instance, that we have an Amazon S3 bucket. S3 is their storage service for object storage. If we have the S3 bucket's ARN, but we need its name, we could have a data block look that up for us and return it so we can use it in maybe a resource block or somewhere else. Data blocks can also fetch outputs from other modules too. Variable blocks, well, these are pretty straightforward. I don't need to explain what a variable is to you guys. But worth noting, variables in Terraform are statically typed. What that means, if you're not familiar with the term, is once you set the variable in Terraform, it cannot be changed. You got your standard variable types: string, array, dictionary, booleans. Also worth noting, all variables in a Terraform module are globally only. You cannot create variables that are scoped only to certain blocks. Then there are output blocks. These just take values from other blocks as inputs, and they expose those values to other modules as outputs. Pretty straightforward with that. Terraform also supports a limited number of types of loops. These are literally all the loops Terraform supports right here. Again, fairly simple to learn. The count loop defines how many of a resource to make. So you could have a count loop define, I want to make 3 virtual machines, or 12, or how many you want to make. A for loop is good for looping over an array, i.e. whenever you have something that you want to do consistently, but with a very small variation. So like suppose we have something where we want to make a number of user accounts on AWS for our employees. We want them all to have the same sort of permissions, but we want to have the name differently, obviously. You could define what you want that logic to look like for each name and loop over an array of names. Pretty straightforward there. And then a for each loop is where you're looping over a dictionary. This is where you have resources that are going to be configured using very different settings. So suppose we have a number of S3 buckets that we need to make. They all need to have very different settings. We could have a dictionary like bucket 1 has setting A, setting B, setting C of this. Bucket B has setting B, setting C, and on like that. So how does Terraform actually know what to do? How does it actually manage this stuff? Because I mentioned before, the Terraform can actually modify the resources it creates afterwards. So how does Terraform actually know about those things that it made? And the answer is the state file. When Terraform creates a resource, it outputs a file, a JSON formatted file called the state file. This is saved to the local file system by default. And the state file contains all the information there is to know about the resource that Terraform created, including its current state, its current, everything about it essentially. It can be stored locally, but ideally in a production setting, this ought to be stored in a remote storage backend because people are going to be having to work on this from multiple different places. Right. Well, you wouldn't version the state file itself. That would be very difficult to version.
Because they're derived objects.
Yeah. We use GitLab at MIM, and GitLab has a built-in storage backend specifically for Terraform state files. It is a super awesome integration. But more commonly, people will store state files in like Amazon S3 buckets and things like that are more common. With GitLab, it's a little bit nicer because you don't have anything else to set up. It's just there, ready to go. I get asked that more often than you would ever believe. I should do a presentation on GitLab. Now, GitLab is not the same thing as GitHub. GitHub is owned by Microsoft, and it does not attempt to do everything. GitLab is an open source, it has an open source edition, and attempts to provide everything that you would need from start to finish to develop, release, monitor, and secure an application. It is super awesome.
So they work the same, sort of, but the ownership different.
Well, GitLab does more than GitHub. GitHub tries to focus more on it focuses more strongly on just providing code repositories and some services, whereas GitLab tries to provide everything you would conceivably ever need.
Okay.
It's a good idea for
They
its
also have a
logo.
pretty logo.
You seem to be
They do.
against Microsoft.
I hate Microsoft. I am not at all afraid to say that. I hate Microsoft.
It seems they've changed it from trying to support open projects to seems to be more Azure support.
Yeah, they're trying to point people to that. A lot of companies are doing that. They want you to get on the cloud because they know if your stuff runs on their cloud, you're going to keep paying over and over again for it, which makes sense for them.
GitLab allows you to have password protected or hidden because it's not all free.
Mhm. Yeah, you can do that, and you can run GitLab locally too in the open source edition, which is really nice. You got a server, you just throw GitLab on there, and you are all set. So to summarize this all, Terraform is an open source infrastructure as code tool primarily for spinning up and deploying virtual infrastructure. The code is not written in a standard scripting language or programming language. It uses something in between called HCL. And the basic unit of Terraform code is a module, and that's simply a folder that has any number of HCL files within it. They're all read in together and executed. A Terraform project consists of multiple modules, and each module includes the fantastic 4 blocks: resources, data sources, variables, and outputs. And that's it, basically. And the created assets are tracked in state files, which are JSON formatted files that are stored by default on your local file system. So I have a quick demo I wanted to do, but if anybody had any questions on Terraform?
Yeah, I have a little basic question.
Sure.
I read that acronym over and over again. What does JSON stand for?
JavaScript object notation.
Thank you.
What is the,
It's a text
you
file.
say the primary focus of Terraform?
Well, it's primarily to make sure that whenever you're deploying infrastructure, virtual infrastructure to run things on a cloud provider like AWS, Google Cloud Platform, that you're not just doing it once and losing all the instructions. If you do it through code, you can take that code that you used to put it together, and you can use it to spin up a testing environment easily. You can have the exact same configurations pushed out to a different environment. So you get something more or less identical to your production platform, but with a couple of very small tweaks, like maybe fewer virtual machines or a smaller scale network or something like that.
It also, and because of the output files that are JSON, you can call that to make other things happen. You have a place you know where you're going to be looking for, and thus your coders are able to start working with those machines and
Right.
get up and running and just make calls back.
You could do that.
What's the, which would you prefer to use, Ansible or Terraform?
Well, they cover 2 different use cases mainly, but I mean, if I had to choose, I mean, my work is probably more more geared toward Terraform. I basically have been trying to get people at work to use Terraform for the stuff that we're doing on our own to build a new cloud service. So, you know, Terraform is great if you're building out a cloud service like this, or if you want to capture the work that you do on a cloud platform as code, rather than just doing it and not being able to reproduce it later on. Ansible is more ideal if you've got servers that already exist that you want to just manage as is.
There's a gentleman that's already proposing to do infrastructure as code. In other words, everything is done in code.
Oh, I absolutely believe people should do that. I mean, the days of pointing and clicking or just, you know, running one-off things is, I think it's wasteful because you're losing the effort that you put in. If you can write it down, if you can make sure that you have it ready to go, stuff like this is like living documentation. If you want to see how this is put together, you can look at the code, you can see how it's put together. It's fairly self-explanatory once you've gotten used to it. And rather than just seeing what you need to do, you can actually use this to cause what you need to happen to happen.
The problem I have with that is a lot of things are misconfigured, thus giving black hackers options to be able to get in. So if everything's code, you really have no advantage of what hardware gives you, which is usually tenfold speed increase, just because it's hardware versus code.
So
Yeah.
you have to run on hardware somewhere.
Right.
I mean, eventually.
But this guy is saying,
Who's
you
this
don't
guy,
need
by the way?
networking switches or anything like that, everything is code.
Yep.
If I can direct it, they can redirect it.
Well, eventually you have to have something that it runs on.
I agree.
I would say
It
put
will
it,
change the whole design of how everything's created.
Well, everything's virtualized in this
Right.
instance anyway. You're not running on any specific piece of hardware.
and if you are worried about it, you can run on physical hardware too, if you want to pay a lot more money. But, you know, with this, virtualized assets are a lot easier to manage, and you have to think about it too, in terms of what do I have time to do? And I was thinking about this too, when I was thinking about, my company was like, how do we make this cloud platform happen that we want to build? Well, we're just a small company. We've got maybe 250 some employees, I think. We don't have a global security team to keep this stuff monitored, but AWS, they've got people working worldwide around the clock, 24 hours a day, looking at this stuff, making sure that they handle a lot of the basic grunt work that we don't get paid for.
Mhm,
So we focus more on the stuff that we do that makes us profit.
mhm.
And we worry a little bit less about some of the other stuff. But there are inevitably cases where you're going to want to run your own stuff, like for certain regulatory requirements, or if you have a very specific business use case, if you literally don't want anything leaving your personal infrastructure. A lot of the bigger players can run their own data centers. But so it's like, do you feel like you can compete with Amazon? And if not, this is an easier way to get started, I think. But again, I'm not the authority on all this stuff.
To run your own hardware, it's a pain in the butt.
It's
Major
terrible.
pain in the butt.
Yeah, but at the same time, Intel still has Spectre and the other flaw, and they haven't fixed it.
No, and that's,
And we're looking at.
Right,
on that,
and
they
so
hardly
this goes against that how? I
Until
don't-
they redesign it.
you know, I mean, you have hardware chips that have a flaw in it. The only way to prevent that is basically running something as a supervisor over top of it that's looking for the attack or looking for something that's gonna, you know, compromise the system and try to prevent it before it gets that far.
And then you have people complaining that
Yeah.
with that supervisor, they've lost performance.
Performance, well, okay, yeah.
So
But you don't have to adjust for that. If you are, the cloud provider can sort of adjust for that to make sure that their customers are going to get more or less the same performance they would expect. And we don't really have to worry about doing stuff like that. It's not that it's a bad thing to want to deal with stuff like this yourself, especially if you want to do it. Like if you want to do it, I'm not going to stand in your way.
Right.
But just from a more practicality point of view, I definitely feel like this is probably the way to go unless you're a much bigger organization that has these sorts of people around. In my case, we don't, at least. Yeah.
And as far as hardware goes, look, we already have still one chip.
Oh, yeah,
Shortage.
shortages. Mhm.
So his comment that is, well, hardware's cheap. It'll
Well,
start going
it's
up.
gonna start going up, but
But not the
same
same.
token, it's the cost of management's the big cost, and the power and cooling and infrastructure to maintain it, if you have it on a large scale.
I think of it this way, if you're mostly talking about Amazon, even if it might be cheaper to purchase something, they're going to have the connections where you're going to purchase it in many
Yeah,
cases.
right.
And so it's
Right.
going to be faster for them
Right.
to get new chips.
Yeah.
They get the first call.
They've got the buying power.
Yeah.
Yeah.
You know, you buy maybe a handful of servers. They go through servers like candy.
The other thing is, as a company, if you buy this stuff, you have to amortize it over so many years.
That's the one.
Oh, I
The
hate
tax
that.
people love you when you just lease the service.
Yeah, this makes it real easy.
You know how much you're going to pay.
No problem.
You pay for what you use, and you can handle peak capacity too. If your capacity goes way up because you've got a Black Friday sale going on, people can't wait to get in for, you don't have to buy double the hardware and just have a massive upfront cost. You can go bigger for one day for Black Friday if you need to.
Or like our, you know, unemployment system's crashing constantly. My neighbors are trying to get in, I'm over there trying to help her, it's like, the system is down, it's just dead. I mean, it crashed. And it's just, you know, they don't use, I don't know what they're doing, but they don't have scalability, obviously, because it's not scaling to the demand on the system.
Yeah.
Yeah, so they get hung up.
But there are definitely advantages like this. So just a quick demo to show you how this works at a very basic level. What I've got here is a test.tf file that has a Terraform code sample that's very similar to what we saw before. I don't use GUIs, so you're going to have to deal with the terminal. So at the top here, we've got our Terraform log that defines we're going to use the AWS provider. Here, I'm configuring this so that we're using the US East 1 region. Yeah, North Virginia. In this variable block here, I'm defining number of instances, which is going to be a number. And this is really just like a comment they throw in here. How many EC2 instances to make. And we're going to start with 3 as the default value. And then this AWS instances block here is going to refer back to this variable here. It's going to use that count loop that we saw before. We're going to count to however many this is. We're going to use this virtual machine template of this size. We're going to attach, okay, this is not the DevOps study club. I forgot to change that. That's the group of work that I started. We give rolling talks on different DevOps topics. Yeah. And then as the output here, we're going to take the AWS ARNs of all these virtual machines and output them all as an array. So again, we're going to use the AWS provider. In the US East 1 region, we're going to start with 3 virtual machines, and we are going to make those virtual machines here. We're going to take their universally unique IDs, and we're going to output that all as an array. Start with whenever you install Terraform, you might think you've got Terraform, you got whatever you need to get started. You actually don't. When you install Terraform, you install the base engine itself. When you want to get the providers installed, you run the command Terraform init. That's your first command. Terraform init will download whatever version of the provider that you've specified. So this is getting that version of the plugin, or it's reusing it because I did this earlier. Okay, go me. The next step is doing a dry run of what you want to do. This is where Terraform really shines compared to stuff like AWS CloudFormation, which I don't think has anything similar to this. If you run Terraform plan, what Terraform will do is it'll read in all the .tf files in this directory, just this test.tf we've got up here, and it will construct a complete dry run saying this is exactly what it will do. This is what it will create, this is what it will modify, this is what it will destroy. And you can peruse that. So there it is. It didn't take long at all. It gives us a complete list of what will be created. Like it'll say this AWS instance will be created. This is all its data. We're going to create numbers of these, and we're only going to know some of this stuff after we've actually created the VMs, of course. Like we don't know what its IP is, isn't it? And this is only the very fundamentals. It gets better. So we get all this information about it, and this is all highly documented, of course, in the Terraform documentation. Yeah. And we even get a list of what outputs we are going to see. The next step is to run Terraform apply. So it's going to rerun this, it's going to make a plan, it's going to say, do you want to perform these actions? We're going to say yes. So Terraform is now making the API calls to make 3 identical virtual machines to that configuration that we defined. We'll give this another 10 seconds or so, and I'm sure it'll be done. It will regularly check in with AWS to see and confirm that these are actually available.
Because that drives you nuts.
Right, because it'll return values saying, oh yes, this actually worked. But behind the scenes, AWS is eventually consistent. It actually does stuff behind the scenes. So even whenever the API says, yes, I'm making this virtual machine, that does not mean it's made. This actually checks on the resources.
Oh, look at that.
Created.
Even gives
Yep.
explicit touches.
Yep. There are add-ons you can get even more advanced with this. Like there's an add-on that I want to try out that allows you to see the cost of what you will spin up. Like it will cost this much per month.
Talk about making friends with your account.
I know, right? You can actually say, okay, this is what's going to cost us to have this environment. Here you go. And this can all run locally, keep in mind.
Right.
You can get a price equivalent calculator from this. It's an open source project. I can't think of the name. Okay, so that's it. The EC2 virtual machines have all been created, and let's take a look at our console just to confirm that. Crap, where did it go? Here we go. This is one of those sandbox accounts I was talking about before. At work, we have a Cloud Guru for our training platform. I got us started with that. They allow you to make these disposable AWS accounts where you can put together a lot of different resources and not pay a thing for it. It's super handy for testing out stuff like this. Where'd my tab go? Here we go. So we're going to sign in. We are going to go to the US East 1 region, which we're already in. We will go to our EC2 virtual machine console. And we will see, voila, 3 virtual machines, just like that.
Small question. Is there anything proprietary about the design of these virtual machines? Are they gonna more or less function with like any flavor of Linux or?
Yeah, they'll do that. Mm-hmm. These are running.
They're not like running on some special chip design.
You don't even know. There's no idea what the hardware is.
As far as the hardware, they actually make their own hardware
Well,
and their own hypervisor, but
I
it.
mean, the virtual machine, I'm sure they emulate whatever they emulate.
Oh yeah.
I'm just wondering, are they gonna be all of a sudden locked into certain development platforms if they commit to it?
Oh, no, I mean, you can use whatever, you can use Ubuntu, CentOS, whatever you want in AWS. I just happen to use Amazon Linux, which is their in-house variant of CentOS,
That's
basically.
cheaper.
Right.
Where they charge different rates.
Oh, yeah.
Mhm.
They're charging based on
Yeah.
expected core utility, things like that. So if they've built it, it's like, yeah, this is lean, it's gonna work this way.
So they give you their own distribution.
Right, but you can also use templates from other distributions as well, like Ubuntu and everything else. Or if you want to build your own, that tool I talked about before, Packer, is super good for that. There's a Packer component. Yeah, it's also made by the same people that made this. You can use Packer to build a virtual machine template with any version of Linux you want, and it'll run just the same on AWS.
What about Podman?
What's that?
Podman?
Oh, Podman. You can install Podman on your instance. You can do whatever you want with them. They're just ordinary virtual machines. They just happen to live on Amazon Web Services.
So virtual machine really started out with firmware. Has it really come around to being generic now?
Mm-hmm.
Because there's a lot of different formats.
There are. They use a hypervisor called HVM with a lot of theirs. That's sort of their in-house, like customized variant of KVM. So Amazon is actually big on Linux. That's what I like about them, unlike Microsoft. I had to get in a dig at Microsoft. I'm sorry.
I mean, Red Hat has their.
They existed.
They'll show you on the doll what they
Yeah.
and made sure that you kept going back to them.
So how does Amazon compare with like Red Hat's cloud services, which is now IBM? They kind of alone.
I wouldn't trust IBM further than I could throw them. But in terms of what AWS offers, they're not really so concerned. They have a different model for getting their business. Like with Red Hat, it's all about the support, right? You can have the open source edition and not pay anything, like you can use CentOS, or you can pay for RHEL or Ansible Tower, or whatever else you want. Amazon doesn't really care what you do. They just want you to run it on Amazon. So they will support a lot of different open source projects too, and they'll make it easy to do it. So like Elasticsearch, MariaDB, PostgreSQL, all very, very easy to get running on AWS with minimal difficulty. And a lot of the basic, the grunt work, the automation, patch management, you can automate away a lot of that.
I know it depends on what you're doing, but what's the base price or subscription price to AWS users do these things?
It doesn't work that way.
Yeah, it's not really like a flat rate where you pay a certain monthly fee. It's you pay for whatever you use. It's all like a usage based, which sounds like a bad thing. Like, oh my gosh, I'm going to rack up these colossal charges. But
Liberty Mutual.
oh, there you go.
Pay for what you use.
Pay for what you use. Yeah.
But more importantly, one of the things that, for example, Amazon allows you to, if you know you're going to run a machine for several months, you can actually buy into a price that's like 1%.
Right. Lock it in.
And things like that. So, yeah.
Right.
Yeah, and my friend Greg, sometimes he jumps on, but he works for a company. They have massive data networks. They have their own server farms in a couple of different places, and he's finally getting them to go to AWS because it's like the hardware costs are just ridiculous. And then
It is
like
ridiculous.
Downtime, and they do these hard reboots where they say, okay, we're gonna assume our servers are down. We're gonna take our data files and move them to this other server farm and try to bring them up, and it always fails. It's just there's too many variables.
It's a pain.
Yeah. So
We got to the same position at work for the most part. Like we were just saying, like we're a small business. We have limited resources. We have a lot of stuff we want to do. Do we want to screw around with doing hard reboots and patching, or do we want to automate stuff and make cool programs? And we're like, we want to make cool programs and automate things.
yeah. So that's basically where he pushed them, and they were in the same boat. They had a group of people who did hardware support, and it cost so much money just for the people.
So what's the scripting language that's used within it to manage?
With this? Oh, this is a HCL. It's kind of like halfway between something like shell scripting and something like Python or Java or something like that.
Yeah. Problem is with shell scripting, whether you use Z shell or Horn shell or C shell, there's format differences and option differences.
There are.
So your scripts that you write, since Bash is everywhere, and there's over 3 million scripts. That's why Bash is so common. But how common is HCL?
Well, they use it in
That's
HashiCorp
another
products.
learning curve you have to go through.
It is, but it's a relatively modest one. What you've seen here is probably a decent chunk of the way toward what you would need to understand to make this in the real world. It's not really difficult to do. So like, I'll show you how easy this is to do. So we've got 3 VMs right now, right? We want to double this. So we'll just change this here from 3 to 6.
You could be doing the simplest thing. and
Terraform
say, "Oh,
apply.
great, look at this, but if you want to do an app, how easy is it? I mean, but good at.
I don't think that's the same, that's not what this is about. It's not a shell like a shell.
Yeah, it's not a shell.
This is more like you're drafting up what's going to get loaded.
Yeah, so this spins up the servers. This creates
So
the
server
servers.
management, basically.
Not management as much as this creation.
It's like this is its own programming language. It interacts with APIs for you. So like you can make programs that call API calls out to AWS and all these things, or you can use this, which abstracts away a lot of that difficulty.
Because you don't have to know the API level.
Right. You just say like, I want a virtual machine, which is what we just said before. And now here we're going to double this here. We ran Terraform plan again. We're going to see all this plan output. We can run this, and now it's making 3 more virtual machines identical to all the stuff that we just made, just like that. We don't need to know the API calls. We don't have to click refresh or track all this stuff. We know whenever this is done, this is done. Then I'll show you one more thing after this.
So the next step beyond this application.
Oh, thank you.
is when you just talk to the computer. Say, computer, spin me up 3 virtual machines.
Alexa.
Hey Siri, make
Hey,
me
Siri, make
make me a cloud platform.
Yeah.
I can't do that.
Siri, make me a multi.
I admit, programming is one of my weak points. I'm more of an admin hardware type. But basically, unless you're dealing with a really large corporation at high volume, isn't it kind of a lot of learning and to learn a new scripting language just to set up VMs, which normally a company may change their configuration a couple times a year?
Well, everything has a learning curve, and it's really about what works best for you. I don't like to make blanket statements like, this is the perfect tool for AWS for everyone. But you think about this in terms of scale. If you're doing a couple of VMs like this, I mean, yeah, I wouldn't do it if I just did a couple of VMs like this. But what I'm doing with this is very much different. And what you would typically do with this is very much different. You would build a virtual network. You would lay all the foundations for that. You would get firewalls set up. You would get everything about these VMs set up here so that whenever you learn this, I come from a similar background myself. I started off I was actually a tech writer, turned sysadmin, now I'm in DevOps. So I have really come up the ranks myself. And when I needed to do stuff like I needed to do for work, this was a lot simpler to me than learning like full-fledged programming, which I'm still kind of weak at, if I'm being honest. I think you could do this.
Well, you see what I confess, I've spent most of my time in smaller offices, and I can't even imagine the scale of having a zillion virtual machines running around. I mean, it's just basically, I have a hard time convincing the office typically to buy a new switch. It's definitely not on the scale that I would normally deal with. So I'm just kind of wondering, if you are going to be scripting a lot of this, is this something where you're kind of like dynamically changing your actual layout just to save money? Cut down on resources being bought from Amazon, something like that, whenever you're, like costs, so many business transactions per month, therefore we're gonna shut down a few VMs, et cetera, that kind of stuff.
I mean, yeah, you can do that. It is definitely more flexible. And if you have a limited budget like this, rather than having to buy all the hardware up front, which is a big expense, you can pay for just what you need. And then you can use the automatic adjustment features to scale up, scale down if you need to. So
it's kind of like pooling all your money, all your
more or
hardware
less.
money into one generic pot that can change.
Right. And it can be whatever you need at the time. So if you need to go really big for a certain period of time, you go big and then you go back down. You are not responsible for maintaining all that.
And you never have to talk to a Dell rep.
Imagine that.
Oh my God, or they're not calling you back. It's like,
Aye, aye, aye.
Once you bring up something like EMC, that's what I really just, that's it. We're done.
yeah, but that's the point. You don't have to.
Well, didn't this all start with VMware, where you can do exactly what you were just saying, about creating a network and servers and all that?
Well, it's definitely come a long way since then. You know, that was more just, we're going to run a couple of things in the office, which you can still do, and a lot of people do still do. But with this, it's more or less, it's a different paradigm entirely. It's like the same shift of having everything physical and then virtual machines. It's kind of like having everything on premises versus having everything virtualized and in a cloud provider. It's like another sort of paradigm jump like that.
VMware hasn't been sitting on their hands, they do that too.
They do, and you can use VMware's cloud stuff if you really want to. This is really just an example of what you can do. You can use Terraform to manage many different platforms.
Does Terraform act like a translator, meaning that you can understand many different languages?
Yeah, it's platform neutral. There are hundreds of different providers, like plugins you can use to manage AWS, Azure, Google Cloud Platform, DigitalOcean, GitLab, GitHub, and I can go on and on.
So it's what they used to call middleware?
It's not really, it's not middleware. It's a tool for, it's somewhere between a scripting language and like a more traditional programming language. It's not really the same sort of thing as a middleware, like a service.
The scripting language that you use for automation?
It's somewhere between scripting and full-fledged programming. It's sort of in the middle there.
In some ways, I guess, could you say that it'd be like, it's more like you're building your shopping list, and then it's going to do something because it's declared, it's not.
Yeah.
But I saw that in Ansible with their playbooks too.
You can do that, but the advantage here is when Ansible creates a resource, like let's say Ansible creates 6 VMs like we have here. Ansible then has no way to track what it already created. So we have 6 VMs right here. So let's change this one more time, and I'll show you like the difference here that Terraform has that Ansible doesn't, which makes it a little bit more ideal. So we're saying, oops, we actually just want 2 of these VMs. So now let's run Terraform apply again and see if Terraform is smart enough to figure out what it needs to do on its own. So it's checking on all these resources, and now it's intelligently saying, I'm going to destroy these 4 virtual machines. It knows it's made 6. It knows you want 2. So it's going to destroy those 4. Ansible can't do that. It creates 6 VMs. And then if you wanted to destroy those, you can, but you're going to have to do some rejiggering sort of on your own for that. That's why Ansible is more ideal for stuff where you've already got a server and you want to do traditional configuration management. Whereas for this is more ideal for deploying cloud infrastructure and cloud servers. Like you could build the infrastructure, build the servers, that's Terraform. And then managing them would be in something like Ansible, like a 3-layer cake like that. And then at the end, if we want to destroy all this, we'll cancel out of that. You can run Terraform destroy, and Terraform will blow away everything that it made.
No notification to people?
No, not for this. Because Terraform uses the state files like this, it's smart enough to avoid managing things that it itself did not create. So if you manually make 2 virtual machines and you tell Terraform, I want to make 4 of those, Terraform will only manage its 4 unless you specifically and manually import your manually created 2 VMs into Terraform's state file here. And that's something that's beyond the scope of this, but it can be done.
Is that how Amazon killed What?
Shut up. So that's about it. If you want to try something for building out cloud platforms, in my opinion, Terraform is a fantastic tool. It's an open source tool, and yeah, give it a shot.
I'm also loving still destroying.
Yep.
This project.
It checks on them. It makes sure, and if it fails to destroy anything or it fails to create anything, it will tell you why. It will give you the error code. It will give you exactly what you need to know to figure out why that thing didn't happen.
You have got me sold.
Start an Amazon account and you don't get charged until you use it.
Right. And they have what's called the free tier. And the free tier is comprised of limited, like scaled down versions of the services that are available for free for a period of time. So like, I think it's like for a year or something. So if you want to make a very small virtual machine and play around with it, they're not going to charge you for that. It's a big thing. If you ever run out of things to play with AWS, because you will never run out of things to play with ever again. I promise you.
Virtually. Yeah, virtually keep you busy for a long time. Well,
If quickly refresh there.
He'll do it. That's on their database system.
All terminated.
And he'll spin up
Terminated.
10,000 servers for like 10 minutes. Spin everything up, check everything out. You know, he might keep it going for a day or two, spin it all back down. They couldn't do that when they had their own hard drive. You know, if they wanted to scale up and see how much they would need, you had what you had, and that was it. You know, with AWS, you said, spin up 1,000 servers. Let's see if this thing scales. You know,
Right. It just
spin it back down. You know, so
it's a beautiful thing.
$100 for, you know, a week or something. They spun up, you know, all these servers, and
Yeah.
it saves a lot.
Oh yeah, you can get a lot of stuff virtualized too. Like traditionally, it's been very difficult to get Mac OS virtual machines. For those of us who have to deal with Mac OS, it's a real pain in the ass. Fortunately, AWS just added support for EC2 and being able to have their virtualized Mac instances on demand. So if you want a Mac just to play with for like a day or so, you can just spin one up, you can take it for a test drive or whatever and get rid of it.
That's cool.
I know, right?
Yeah, seriously.
But there is a limitation with that imposed by Apple. They force you to have that Mac active for a period of 24 hours because Apple.
Oh, billed by the day, or do they bill you for?
They charge you by the hour for whenever it's up, but Apple says you have to have it for at least 24 hours. So it's not AWS doing that, but somebody has managed to, you know, virtualize Mac OS, which up until this point has been essentially impossible.
Yeah, Apple wants to get a hold of every penny they can out of you.
That's right.
Why you don't like Apple? Any other questions, or?
I got nothing else if you guys don't have anything.
Thank you so much.
Great job. Very good. Great, yeah, it's really neat.
No, I did it at work too. I started a group at work called the DevOps Study Club because I said,